All right. Thanks, everybody. Be sure to put your headphones on so that you can hear me. I want to make sure that everyone can hear me. Make sure we're good. Do a sound check. Check 1, 2. You good? Good. I see thumbs up over here. We're good to go. I'm going to go ahead and take mine off because I'm speaking. But if you ever, first rule is that if I say something you don't understand, you give me one of these, and we stop and handle the question right in the moment. Is that good? Okay. Good. So we're talking about Proc FCMP. And we're going to take the square root of -1. We're working with complex numbers and vectors. And I'm thinking back to when I first started as a SAS programmer. I had hair, and they gave me a stack of 52 floppy disks and said, go install SAS on your OS2 machine. Oh, you were there. Yeah, that was my first day. And I'm learning, trying new things in SAS and trying stuff. And I get to the square root function, and I'm like, I'm going to do it. And I try square root of -1. What do you think happened? Well, I didn't get an I. I got an I full. I got an I full of messages in the log. And I said to myself, okay, SAS only works with the real numbers. And I kind of left it at that, but it sat with me for a number of years. And so what this is, I figured out how to work with complex numbers and multidimensional vectors easily and create tools around those so you can use them. Now, my point here is that you can do this too, and I'm going to show you how. Because you guys are all smarter than you think you are because SAS is that kind of a programming language. So let's take a look at the next one. Oh, by the way, take a scan. That will take you to my landing page for everything that I'm encountering here. Bookmark that page. It gives you everything for this presentation. It gives you the source code, the documentation I put behind it, and I've also been uploading my notes from other sessions that I've been to so you can see what all you might have missed, or contact me and say, hey, you got this wrong, and then we can correct it so we can work together. Everybody got it? Okay. So next, SAS is really good, and we all know that. That's why we're here. It handles a lot of really good things. Has a robust selection of trigonometry functions, lots of financial functions, all kinds of things, but it is lacking in a few areas. And that's okay. It's not going to be able to do everything. So, and some of those areas are complex numbers and vectors, okay? Then the high precision arithmetic, images as numbers, very large numbers. How about arbitrary precision arithmetic or symbolic mathematics? These are all other areas to tackle. We're going to focus on the blue ones because they're really simple to teach from. Complex numbers and vectors. So here's your quiz. You didn't know you were going to start off with a quiz. What do you do if SAS doesn't have something that you need? That's it. You build it yourself because you can do it in SAS. Now, we're going to put together 4 builds, real simple ones. Call square root neg, okay? Call vector sum, and then 2 functions, vector mag for vector magnitude, and dot prod for calculating dot product. Pretty simple. Once you see how this is done, you're going to be able to pull out your 8th grade math book and say, oh, okay, I can keep going from here. So let's take a look. SAS does give us a lot of tools to build from. We're going to use arrays and Proc FCMP. You can use loops and SAS procedures and data step logic and of course the macro facility, which I love. We all love that. Some of us love it a little too much, but we're going to focus just on arrays and Proc FCMP. Now the reason we're going to go with arrays is that we're going to maintain an ordered list of values, which says use arrays, right? Yeah, everybody's looking at me like, yeah, I knew this so far. That's right. You did know this so far, okay? And then why Proc FCMP? Because we're going to make functions and call routines that will work and operate at the record level in the data set. Now you could use macros, but it's kind of harder to digest because the macro compiles at a higher level. So what we really need is to build a function. Is everybody with me so far on approach? Okay? Pretty simple. And why not SAS macros? Because it's the wrong tool for the job, essentially. I love macros, but use the right tool for the right job, right? Let's look at complex numbers and focus in on that. What exactly do we mean by complex numbers? If you're not familiar with the term, we're talking about the square root of -1, the square root of negative numbers, which your high school math teacher said you can't do that, except for when they say, yeah, you can, we can do it with complex numbers. We like to express the answer to the question, what is the square root of -1, with the letter I. That represents the imaginary number. Unless you're an electrical engineer, and then it's J, because they don't know how to spell, right? Well, they use I for current, so it doesn't make sense. So that's how we're going to work with it from here. And then when you build a complex number, you have a real portion and an imaginary portion. Do I need further explanation on that, or are you all with me on that page? I want to make sure I give you what you need, but if you're missing something, we want to fill in the blank and bring everyone with us. Looks like we're good. Here's a fun little data step. Data null, R, the real number is -1. C, the complex number, is the square root of R. And then put R equals C. What happens? Well, there's what happens. Yeah, note, it tells you, hey, Paul, you're trying to take the square root of a negative number. Stop it. Well, it doesn't say that in quotes, but it's really what it's telling you, right? So why does it do that? Because by definition, in the documentation, argument for the square root function must be non-negative. Okay, I get it. But for complex numbers, we've got a real component and an imaginary component. Now I'm going to go with Cartesian expressions, which is x, y, okay? Yeah, if you want to do it in polar coordinates, great, code it yourself. No problem. Doesn't bug me. It's just math. But for this example, we'll look at Cartesians, and we're going to get a plus bi is going to be that complex number. So a complex number is an array of 2 elements. Simple, right? So simple, it's easy. So if we're going to write up call square root neg, what would the documentation look like? It might look like this, where we're going to, the call square root negative is going to assign the square root of a number, a scalar number, a real number, as a 2-dimensional array in those components, where the first part is the real and the second part is the imaginary. And I'm putting this in a call routine. Why a call routine? Because we're going to get 2 outputs from one operation. If we only get 1 output from an operation, we can use a function. If we get more than 1 output from that operation, we need to use a call routine, and then we're going to assign it to a declared array. Everybody with me? Good? Good? I see lots of nodding heads. So, the next part, let's make it. This is their favorite part. procfcmp, and I'm going to write this out to the work library. Okay, we're going to build a subroutine. That's our keyword there. Go ahead and take a picture. Oh, and you can download this also from my GitHub, so definitely do that. And out args complex, that means that that's what we're going to write back out to the data step, is whatever I call complex here, and here it's that 2-dimensional array. Okay, if real is missing, then we get missing values back out. If real is less than 0, then the complex one, the real portion, is 0, and the imaginary portion is the square root of the absolute value of that real number input. Right? Pretty simple. Otherwise, we're going to take the square root of that real portion, and then the complex, or the imaginary portion, is 0. This is basic operations for complex numbers. So let's do it. Now we're going to do this. Here's our quick little data set. I've got a complex demo data set. You've already got it. It's 5 records, and it's got different options for integers for A and B, and for C. So we're going to create an array that we call C, and it's made from the variables A and B, which are numeric variables. So when we run that, if x is -2, then A is 0 and B is 1.4142, whatever it is, right? And then if x is -1, then a is 0 and b is 1. For 0, then it's 0 and 0, and so forth. So we're putting that out. So that's what we get. That's the right answers. That kind of looks silly, though, doesn't it? I mean, it'll get you what you need, but let's see if we can make this a little bit more human readable, okay? So I've made a function here called complex to car. You can come up with a better name, trust me. You won't offend me. So what we do in complex to car is given an array name, that two-component array of the complex number, it's going to return it in a string, a character string of a plus bi. And if you want to do it in polar coordinates, then you do it in polar coordinates. I don't mind. Here's what it looks like. We're going to build that function. Now instead of building a subroutine or a call, we're building an actual function, so we declare it as a function. And then all we really need to do there is just return the value and run the calculation. That's it. So now when we run that in the data step, we've got our first call, square root and egg. Then we're going to make a variable called complex, which is assigned to this new function we just built, complex to car, and then put it out. And there's what it looks like. We get 0 plus 1.42i on the end, and then 0 plus 1i, and so forth. And you get your answers, and it builds you a text string. So you have now just made a function and a call routine that you can use all the time, okay? So that's what you've done there. You're starting to learn to build functions and call routines. So a quick summary, call, square root, and egg. We're going to perform the square root and returns a complex number in the form of an array. You've got an input and the output. Complex to car, that's going to return a Cartesian complex number in a text string when you give it the array of a two-dimensional complex number that you've already declared. Caught up? Everybody's giving me one of these. Does this look simple to you guys? It's supposed to look simple. This is supposed to be, I'm going back Monday and doing this, okay? And you'll be done in an hour. That's the point. So let's talk about vectors now. Vectors in general, yes, a complex number is a vector. It's a specific kind of vector. It's a two-dimensional vector. What if you have a 100-dimensional vector or a 5-dimensional vector? Okay, great. Let's do some more general processing with that, where we've got magnitude and direction. Now we're still going to stick with those Cartesian coordinates. And now I've looked this up. You can have a one-dimensional vector. I don't think you should, but you can. I don't think you can have a zero-dimensional vector. Talk to your math teachers about that one. I can't get a definitive answer. So I'm presuming for these models that you have at least one dimension in your vector. Okay? And again, the representations, you can use Cartesian, polar, cylindrical, spherical, component, order, a unit vector, or a matrix of some kind. I don't care. Write the code to handle it the way you want to handle it. But if you keep them in that Cartesian coordinate approach with A, B, C, and numeric fields, then the math underneath, the operations, is going to be identical. All you care then is how do you display it. Right? So, vectors are essentially an array of any number of elements. That's all it is. By the way, vector technology, really big in any kind of AI calculation. Really big in any kind of forecasting. A lot of practical applications here. What's the practical application of complex numbers? Well, any kind of circuit theory, any kind of timing, any kind of phase shifting. So you can go, yeah, you're doing it, aren't you? Yeah, there's a lot of practical applications here. Let's take a look. We're going to make next vector mag, determine the magnitude of a vector, dot prod, which is going to calculate the dot product of two vectors, and call vector sum, which is adding two vectors together. Okay? And again, using the Cartesian representation, using one or more. In my example, I'm going to use a 5-dimensional vector. When we put the data step together, it's going to look like this. And I've got those two functions that we're going to build, and then that call vector sum that we're going to grab, and we're going to build that one. So here's the function for vector mag. Pretty simple. You've got a radicand of 0, and we're going to do I equals 1 to the dimension of the vectors, okay? Loop through it, calculate that dimension. This is right out of your algebra book, right? And then we return the square root of that radicand, and that gives you the magnitude. It's real simple. You can look it up on Wikipedia if you want, and then you just build the step. Does this look like pretty much data step code to you? Guess what? Because this is pretty much data step code, except it's wrapped with ProcFCMP instead of data step. Okay? Go ahead and take the photo. Now, here's the vector sum. I'm sorry, I got this thing about line breaks. Oh, and by the way, if anybody ever knows, if you know Michelle Buchecker, you be sure to tell her that I'm putting a space in front of my semicolons like she taught me to. Nobody knows Michelle. Oh man, she was one of my trainers early on. She always said, this is bonus material. Put a space in front of your semicolons. That way it's easy to find the missing semicolon because they'll all stick out. Believe me, it'll save you hours of agony, okay? But back to this, the vector sum, we've got the augend and the addend, or the two vectors that we're adding together, and then the sum vector, the result. And we want to make sure that the dimensions are all the same. So we check that first. If the dimensions are not the same, then the sum is going to be set to missing. Because you can't add together vectors of different dimensions and get an answer. That's the way I wrote this one. Now, if you want to write it different, go for it. I don't mind. You know, you might have different business rules where you can incorporate that. Great. And that's basically the process. You just add them up, determine the sum, write it out to your new vector, and you're done. And then the last one, how to calculate the dot product of two vectors, okay? Now, what we're doing here is that, again, the dimensions need to be the same, just like the other. And if everything checks out, we set the total of the dot product to 0 and then calculate the components through a loop. And then we write out the result right there, return that total value. Pretty simple. It's just basic algebra. So when we run this up here and we use those the two functions in the call routine, we get this. The magnitude is 12.409. We get the components C1 through C5, and it calculates and shows those explicitly, and calculates the dot product between A and B to be 156. So you've now built another call routine and two more functions. Where does this take us next, right? Next is you can start adding some quality control checks. Okay? You can put in some error messages and warning messages in the log if you want to, and have them only, whenever it encounters a missing value. You might want to put a note in the log that you encountered a missing value, kind of like a SAS function does. And I've got some in my downloaded programs. I'll show you how to do that, okay? You start creating some usage guides and support material around that. That's going to be helpful too. Volume testing. Go to about 10 to 100 times the volume of what you think you're going to run through it and see if it functions on your system without falling apart. You can build more functions and routines. And by the way, I want you to think of some functions or routines that you might want to create. And we'll talk about that and share that here right when we're done. Because, like I've been saying, you're smarter than you think you are. You've got more power. Yes, you got one already? Oh, wait a second. I got to put my headphones on so I can hear you. Go ahead. Oh, Colby, we need to get the microphone so that I can hear you.
Is that better?
Yes.
Awesome. So I've actually never used ProcFCMP, but can you, once you've compiled a function, can you reference it in another function?
Yes, you can. That's a very good question. The question is, once you've compiled the function, can you reference it in another function like you're building in ProcFCMP? I do it all the time. Now, the important part is that it has to have access to the library that stores that function. I'm putting in these examples in work, so you got to recompile it every time. But you can store it to a standard location for your site and keep all your routines there. So then, if everything checks out, it works good. I've also, by the way, got a utility that you can check and see if a function has been stored in the proper location before executing. And in case you want to package that as a Sass package, see Bart. He'll show you exactly how to do that. I highly recommend that. Defaults and overrides, edge cases. What happens if somebody puts in a character field to your square root of -1? Well, you could just get a regular error, or you could scrub it and be ready for it. Practical applications. Let's talk about some practical applications here. I think I'm going to keep my headphones on because I can hear me a little bit better too. How are you going to use this? Signal and frequency analysis. So you were talking about signal and frequency and circuit theory right there. Distance models. Gee, do we ever have anybody work in logistics? Okay, we're all in logistics, right? Multivariable probability, movement and direction forecasts, joint distributions, 3D positioning, wave systems. This is not everything that you can do with vectors and complex numbers. This is the stuff that I thought of off the top of my head that will use vectors and complex numbers in your analysis. There's a whole bunch more. I really believe we're going to have to create a different kind of math down the road to be able to handle some of the processing that we're going to be doing. I think you guys can understand that. So let's take your turn here. So we're going to, Colby's going to bring the microphone down. I want you to take some time to get ready to share some of your ideas on what you think might be a good function or call routine to build. We're not going to have time to build it, but Sass provides you those building blocks, and then you build what you need. So let's take a 60-second brainstorm. Does anybody have anything that's popped to their head on what they might want to have for a function? Pro tip, get somebody to go first, because then the rest of them will follow.
Two things. The name, Troy Martin Hughes. He wrote a wonderful book about ProcFCMP. He explains all the details. Very good book. Check it out. Okay, so all functions what I wanted to have, I already have in base plus package. So function which applies format for concatenation. Check it out. And you mentioned earlier functions for adding long numbers. I've got a bunch of those. We need to talk about it.
Yeah. Yeah, so different kinds of numbers, or larger numbers, or accuracy, varying accuracy. You can be more accurate than Sass restricts. You just have to do the math to make it done. Here's an idea for a function. Does anybody ever been in the middle of a data set or a data step and you wished you knew the number of observations in a data set in that step? Yeah? Well, you can build a function, an actual function, that will look up the number of observations in any named string data set. You can do that. How about the number of variables in a data set, or the existence of a variable in an external data set? How would you like to be able to look up the nth record of a flat file in positions 15 through 18 and return that as a string to a variable inside a data set? And that file location can be named based on a variable or string in the data step. Yeah. You can do that.
Along the lines of getting the names of the variables or whatever, when you're stacking data sets, and sometimes it happens that string variables are a little bit different, the function determine the max length of that column, all the input data sets, and just make that the new length, so you won't get the error or the warning when you're stacking columns of different lengths.
Yeah, that's a great application there. Smoothing and standardizing data creation. Okay? That big one. That's a big one. Bart's got another idea.
Thank you. Just an observation. For setting the length, we have to be a step ahead, so we have to do it on the macro language level. Because function will be already available only available in the execution time, so that will be too late for getting the length. So that we have to do with macro language. But another function. Let's imagine that you have. I'm already talking about that function on Monday. Let's imagine you've got a SAS expression in the form of a text string, and you want to evaluate the value of that expression against particular observation in the data set, right?
Yeah. Here's another function. I've built this one. This one will blow your mind. What if you want the result, and we got 4 or 5 minutes and we're gonna wrap up. What if you want to run a SAS program and get in its own separate private session and get the result of a file created from that SAS program written back to your data set while you're on the 15th record of that data set? I've done that. I don't recommend it for large steps because it can be taxing, but the do subble function can allow you to run an independent SAS session that could create a file to a declared location, and then you can read that file in, the result of that file that was created, and get that result. So that's kind of crazy, but it's certainly possible. So those are some great ideas. I hope you guys take those. We're gonna keep moving forward because we really are just about done. So the brainstorm share is, I wish I could do blank in SAS. The answer is you pretty much can, you just gotta figure it out. And SAS gives you the ability to figure it out. And you can do all of this and more because you're smarter than you think you are. And SAS gives you the ability to express that as a programmer, okay? So in case you missed it, this QR code is going to take you to the source code, to my landing page from Innovate. So do go ahead and bookmark that. This is the same one that I started with. And that's the end. So I'm going to stick around for questions and answers afterwards, but I know we got another session coming up. So any final questions from the floor?
I was going to say, if you have the event app, Paul's slides are there available for download as well.
Excellent.
Don't miss anything.
Great. Contact me with any questions. If you come up with a better solution than me, let me know. That's all I care. So, thank you. Thank you very much, everyone.
Thanks, everyone.